My presentation is going to be about patterns for infrastructure as code. My name is Andrey, and just a few words about me. Primarily, I'm a Java developer, Java Groovy developer, Clean coder, obviously. I do a lot of automation for my clients, so some people may call me a DevOps guy, but I don't like this. I'm still a developer. I have developer attitude, but I like automation as well. I'm co-organizing Latvian cross-section community. I'm from Riga, and also co-organizing conference there called T.A.K.E, which is going to be in December. You can find me on Twitter. It's quite easy, coding Andrey. So follow or give your feedback. But let's continue this talk. What this talk is about. So basically, it's a collection of patterns. It's a collection of patterns representing different things in infrastructure as code that I found during my journey for the last few years, when I was using pretty much every provisioning tool, like Ansible, Chef, and Puppet, and some others on top of that. And the thing is that this presentation actually is work in progress, so it's never done, probably. And feedback from you guys is very welcome. If you have any new patterns, any other things, just tweet, write a blog post, write me an email. I'll try to include it in the next version of this. This presentation is a work in progress to try to collect different patterns that I've seen and probably make some names for them. So what is infrastructure as code? Well, we can take this from the most trustful source on the internet, Wikipedia. Infrastructure as code is the type of IT infrastructure that operations teams can automatically manage and provisions through code other than using manual process. So everything that we can do for creating, provisioning our software components is maybe called infrastructure as code. During my journey and during my experience with different clients, I found out that we kind of have three main players in different types of tooling that exists. One of them is images, basically the base images, the base operating system images or base container images that you use to start up your infrastructure to make it more kind of immutable and to give you a good start. The next one is called declaration. So, by the way, how many of you guys have used any of the tools like Puppet, Chef, or Ansible, Salt? Actually, some other, well, not that many. Wow, like 5% maybe. But still, most of those tools actually they differ a lot from, for example, simple scripting tools like shell scripting, in a way that actually they declare the state of the configuration of the server or the container that you want to have. So they declare it in a way. So Puppet, Ansible, Chef, and similar tools, they declare the state. They don't declare the action that you want to do. It's about the tool will handle that, but you have to declare the state you want to apply to the server. So that's why I call them declarations. And the last one is tasks. So basically everything that goes beyond those two things actually is scripting things and operations, orchestration, all this stuff goes to the last part, which is like executed maybe on less priority basis and on a half basis and stuff like that. So the main players are image definitions, provision declarations, and automation scripts. And there are many tools that cover each of those areas, each of those players. Basically, for image creation management, if you need some example, you can use Packer as a tool from HashiCorp. Docker is kind of providing things for creating base container images, so you can build your containers, base your images using Docker. You can also use various cloud providers to have your base images and build them in one way or another. Sorry. State declarations, as I mentioned, Puppet, Chef, and Ansible, and for automation blocks, you can use anything, starting from simple SSH and the shell scripting to any scripting language that you can imagine. Python, Ruby, Groovy, whatever. Everything works. And as I mentioned, there are quite many tools in any of the areas, and this is a table from periodic table of DevOps, how they call it, from a company called Xebia Labs. And I think it's far from being complete, actually, because it has a lot of tools for different areas, for version control, for automation, for server discovery, for version management, for everything. But again, it's far from being complete, so there are much more tools than that. But it's a nice way to see that. So, and because of all those tools that exist at the moment, we can actually say that everything that we have is actually code. Everything that we do about our provisioning, about server infrastructure, about deployments, about application code itself, it's code. The test as well. And everything obviously should be version control, and everything, and the way it gets onto the environment, onto your infrastructure, should be through automation. So basically, it's kind of similar in the way you deploy applications. You usually have probably some kind of automatic process that is exposed maybe in some UI, for example, Jenkins. You see project say deploy, and your application code is being deployed. This is kind of continuous integration, maybe continuous delivery. But you can also go to a more automatic way, meaning that as soon as someone commits something into version control, it's getting deployed automatically. And we used to apply these things to application code because this is kind of what should be done to achieve the continuous delivery and continuous deployment stuff. But this also can be done with the infrastructure as code. So you can create new environments, you can provision new environments, you can do whatever you want on any commit. And that's becoming less and less expensive with all the virtualization solutions, with all the cloud solutions that we have. That's becoming less expensive, and it's kind of a way to go as well. So let's go to the body of this presentation. Let's see some patterns. And again, I split them into some logical groups. For some, I didn't find any group, but we'll put them in the end. So the first one is for working with images. One of the patterns that I think has a name for a long time, and I think that's the oldest one I know, is called golden image. That's basically a situation when your operations guys, or anyone supporting your system, have a base image of the servers or something that they used to start the environment, and they never dare to change it because it's too hard, it involves too much time, and versioning is also hard because you can't really recreate the servers from a new version of the image if it gets created. So it's a lot of problems surrounding that. So this is the oldest pattern I know about. And to kind of fight these kind of things, tooling exists for that, and I would call it a pattern called reproducible images, because you can actually have tooling like Piper and Docker to help you out to build the base images for your infrastructure and reuse those images during your provisioning tools. So this is actually a move towards more like an immutable infrastructure instead of infrastructure that was created once 5 years ago and everybody is kind of caring about that too much. Okay. Well, it's not that much about image because usually what goes onto the image part is very simple and very basic because all the other tools take care of the complexity of application deployment and provisioning. But let's talk about another thing. Let's talk about secrets, because I guess most of you guys have passwords and private keys, SSL certificates, stuff like that, that are being used in development environments and are being used in production environments. And unfortunately, I've seen many times that those secrets are not really taken care of very well, and maybe exposed to some extent. So one thing that when you create a provisioning code with any tool, doesn't matter which one, it's important that you isolate the secrets. Because everything is code, but secrets are not code. They are more data, and they are very sensitive data because and that's why you have to protect them. So secrets should reside in a different location from a code, and they should be injected into the code being deployed in the very last stage. So we have like database passwords and SSL certificate. They should be deployed to production, probably automatically, but at the very last stage, and it should be kind of controlled. And of course, isolation is one thing, but another thing is actually encrypting the secrets, because sometimes you can find, and actually in GitHub you can find a lot of AWS keys, and people actually specifically search for those to use AWS infrastructure so someone will share the key this way to start Bitcoin miners and stuff like that. So even if you rely on like your own version control repository that's located in your own premises on your organization, still it's important to encrypt things. Of course, yeah, it's usually that you can probably encrypt your hard drive, so everything that's get from version control is always encrypted. Nobody can get it without having a password to your laptop or to your production machine. But you can also encrypt files directly in the version control. That means that you can still commit them. You can still commit them together with other files, but in an encrypted form. Another option, you can actually use the vault service to demand secrets when you need them. There are several options. So one of the easiest ways to encrypt things is use GPG. I mean, it's available on most of the systems, maybe not Windows by default, but you can actually get it on Windows as well if you want. And if you use a version control, you can just encrypt the secret file, sensitive file, and put it in a version control. Well, it's not very convenient, but it works for certain situations. The good thing is that, for example, for Git, there's a nice tool called transcript, which allows you to, which basically sets up a hook in your local repository to encrypt the files as long when you push them to the remote server and decrypt them when you pull them back. So basically, when you work with those files on your laptop or on your machine, you get them in an encrypted form. But they always send into the remote machine, into the remote server, into the remote Git repository in an encrypted form. So that's very convenient in my opinion, because you still work in the same way you were before, but everything is encrypted. All sensitive files are encrypted in the version control. So nobody without a master password has access to them. That's very nice. Also, there are some vault services that are available. So something that is a bit more integrated into the tooling, or something that you have to have a special client for. So there's a vault program, software called from T.A.K.E that is very advanced, and actually many enterprises use it now at the moment to get least secrets and centralized secret storage. Chef, Bab, and Ansible have specific plugins or built-in functionality to actually help you out with encrypting parts of the secret information. And so speaking about that, actually the anti-part, and I would separate, is that people don't really care about security early enough, and they say, it was secure enough. We just, put this production password into the version control and let the automation be proceeding very well. But in the long run, it doesn't really work, because at the point where you need to isolate and decrypt the secrets and make the process more secure, it will be actually a pain in the ass to do that, because everything was already set up in the way that it assumes that it knows the password, and the password is in version control in an encrypted form. That's usually a pain to introduce it, to convert it in a more secure way. Okay. Well, security is important, but let's talk about code organization of different provisioning tools. And I've worked with, as I mentioned, I've worked with many of them, and most of them have some same issues when you see people not really experienced with the code basis and code, the tools organizing code in probably the wrong way, not really in a simple way. One pattern actually anti-pattern that I've seen a lot, it's like, yeah, let's take Puppet, let's take Ansible, and yeah, let's just say that we are the owners of the configuration of these packages, and we put all the configuration files into our provisioning tool, and we make our provisioning tool the master of those. And the problem is that basically what you do, just instead of expressing yourself of what the intent of the configuration was, you have a list of things you just copy over to the configurable node of the configuration. So if you take Nginx, you basically an HTTP server, you have a list of files you have in your provisioning code, and you have a simple manifest or cookbook or whatever that specifies that we need to copy those files from our provisioning node to our configurable node. And the thing is that it works. It works fine. And the thing is, most likely your configuration files contain some valuable information about your architecture, your components. But the thing is that it's not really expressed that much in the code. And all the same thing happens in Ansible as well. And Chef Ansible, sorry, this is Puppet code, but it could look like this is how Ansible code could look like. And the problem is that you're actually hiding the abstractions. Because files and packages may not be the right abstractions to express the intent of your configuration. Because most likely your configuration, the high level of manifest or playbook should actually define the main intent. And if you see a list of files being copied, then you actually hide intent. The high level abstractions are hidden in the configuration files, but they should be on the other level. And yeah, and definitely there's a much simpler way to copy files. So don't go that way. Try to use the facilities that the provision tool provides to actually express better abstractions, build better abstractions for ID systems. So instead of, if you take the example of Nginx again, we don't really want to configure files and to copy packages or stuff like that. We actually want to configure, let's say, upstream server, or virtual host, or a static directory that is storing some static content. So these are much more, will be understood much better by those who will try to read your code, because this actually expresses your intent way better than copying the file. And that's what I've seen in many provisioning tools, that you actually hide. To actually understand what this provisioning tool is doing, you have to go very deep inside. You have to decompose the whole thing and the whole process to verify what's going on. And most of the provisioning tools actually give you an ability to make it a better design. And for that purpose, actually, I think the DSLs, or any kind of high-level code, will actually help you out to express your components of your system better. So if your system has some well-recognized components, like HTTP proxies, applications, web applications, databases, stuff like that, you can use the facilities of the provisioning tool or any scripting tool to actually build this language that will express the intent of your configuration much better and on the right level. So instead of copying the files, you say, I want the upstream server, I want the proxy, I want the downstream server, or something like that. So something that expresses the components of the configurable component much better. So in a pseudocode, or this looks something like that. The HTTP proxy consuming the business application databases connected to that application. So something like that. And this is very abstract, but every provisioning tool actually allows to build you that. But on the other side, you don't really need provisioning tool. If you're still using something like Bash, Perl, Python, any scripting language to build your provision code, you can still use the facilities of the programming language that you use to actually build the proper abstractions and to build a DSL that expresses the components, the dependency between components in a much better fashion than just copying the files. And that's all goes back to the clean code and to expressing your intent, to be a good designer as well, like Alex said in the keynote. Because if you don't follow that, you make very hard time for the ones who will read your code after you. And unfortunately, I've seen many examples of that. Very badly structured code that is very hard to understand and very hard. It's not navigable. Okay. Let's look at some simpler examples, maybe some obvious examples. What are called incremental configuration. So again, not to copy the whole state, not to declare we're the masters of the whole configuration of the package. We can actually do some smaller injections into the configuration, because usually the packages or the applications we configure, they have some default state which is good enough. And instead of duplicating that whole thing to find this fancy file copying thing, we can just inject some of the configurations that can configuration options or configuration components that are important to the system that are different from the default state. So the conventional configuration kind of. And this can look like this. So instead of saying that we want to configure everything in the package X, we actually just configure the parameter A of the package X, and all the rest is coming from the default state. And again, provisioning tools provide different ways of doing that. So if we're talking about replacing a line in the file, then you can still use some set and regular expressions. If we're using Puppet or Ansible, there are things that can be used like inside the manual provisioning code to actually inject configuration options into the default state. So in Puppet has file line and guess, and Ansible is line file and replace. In Chef, we have the full power of Ruby, so you can do that as well. Another thing that if your provisioning module actually has to declare itself as a master of the whole configuration, you still can give an ability to anyone who is depending on your module to extend that module actually to allow to compose the whole package configuration, application configuration of different blocks, and you can express that with abstractions. It could look like this. So you have a package X, and then you have service A1, component B4, which are kind of part of your. they're building blocks for your component itself. But in the end, what they configure is the whole configuration of the package X. But in your component itself, in your provisioning code, you actually express it in a much better fashion. And for configuration composition in different tools, like in Puppet there's config module, and in Ansible there's assemble module, in Chef you have partials, and also you have templating languages inside in all of them. So you can use those to actually compose the configuration, full configuration of many blocks and of many calls in the provisioning code. Another thing that I found useful quite often is what I call extra packaging code, is that sometimes when you have developers expressing the configuration of the application using Puppet or Chef or Ansible, whatever, they try to, like again, to express too much. Sometimes when there is a more strict boundary between devs and ops, and something when you have to actually fight it in some way or make around of that, you can actually, instead of giving the provisioning code or being the master of the provisioning code, you can actually package your application in a well-recognized format. So if it's deployed on Linux environments, you can take the RPM or that package, and you can package some of the default states into the package, and give that package to your operations guys, who can write much simpler provisioning code around that, because it will provide the default code, and it's actually not that hard for developers to grasp how to create those packages and to publish them to artifact repository. And basically, instead of, in the provisioning code, instead of specifying that I need component A1 and B4 to be part of the configuration, I actually put it in the default state into the packaging code, publish into the artifact repository, and then the provisioning code for deploying that package looks very much simpler. So, and this could actually work very well if you have more strict boundary between devs and ops. Yeah, there are many different package formats, starting from simple jars in Java and just zipping the whole your application without configuration. It's also, why not? RPM, that MSI for Windows, gonna work fine. Container images is also another way to package. Actually, to me, it's just another packaging format, and of course it needs more infrastructure, but that's still, it's just another packaging format. Okay, anti-pattern data is code. Well, the thing is that sometimes when your provisioning code looks like, have a lot of entries for different users, for different servers, that means that maybe probably you're doing something wrong, because data has different life cycle than your provisioning code, and provisioning code should mostly serve as a template rather than a full collection of all the possible settings. And probably to fight that problem with having too many copy values and your provisioning code, you can use some things like continuous discovery, for example, and configuration discovery, and instead of putting the configuration, the different settings of configuration that vary on different environments, you can actually have the auto discovery or service discovery data source, where you actually store this configuration. It probably has a different deployment process for that, but still your provisioning code becomes simpler because you just keep the template of the environment, template of the servers, template of the configuration, but the actual values injected to those configurations, they are stored somewhere and controlled by a different way. It's one of the types. And there are many tools that at the moment help with that, like KCD, Eureka, Zookeeper, Console, and actually many others. There's many other options for that. And speaking of that, because somehow this data should get into the configuration discovery, it could be that this you have somewhere a data file or a database, or you have some query API that could even be stored somewhere in version control, no problem. That is deployed to this configuration discovery server. Also, sometimes you can have a dynamic infrastructure which starts servers on demand. And for that one, you can actually use something like infrastructure query. And for example, for most of the cloud providers, they support it. They support APIs, and they actually have modules for different provision tools to inject the inventory of your infrastructure into the provision tool and use that to combine that together, the infrastructure query and the information about the template provision code. And of course, usually you don't provision one server. You actually, sometimes you have, most of the cases you actually have an environment that have more than one server or more than one container. And it's important to also try to automate that as a template, as express it as a full configuration block of the whole environment that you need for deploying your application. And again, there are tooling for that. Tools, well, if you're working locally, you can use Vagrant, of course. If you work in Amazon, there's AWS Cloud Formation. If you want to work cross clouds, there's a Terraform, which allows you to create cross cloud and cross region deployments of different machines. So you can basically create a template and then all things that you want to provision in the cloud, servers, networks, whatever. For Docker, you can use Docker Compose and Kubernetes API to also define things like that. Okay, let's jump to the next topic, code quality. So one thing is that I've seen a lot is that all these provisioning tools, all these scripting tools, people treating them as a configuration. So something that is low level, something that nobody cares about or cares about on a different level. But the thing is, it's actually code. So first of all, it's not this version control. And you'll be surprised, but still I've seen some clients where they don't keep public code or Ansible code in version control. They keep it on the server somewhere in production, but it's not in the version control. They don't audit that. Also, they don't really do code reviews. You just copy the files from Stack Overflow and go ahead. That's something that should be applied because it's code, obviously. And you'll be surprised also that most of the tools actually have static code analysis tools on top of them. And also, testing is possible. So of course, it doesn't make a lot of sense to do unit testing of the provisioning code because this has a lot of side effects. But integration testing actually makes sense, and with all the virtualization that we have, actually it's quite easy. For testing in FreshX code, I know two tools at least. One is Server Spec, which allows you to specify what kind of state you want to check on the server, and you can use it as a monitoring tool as well, or you can use it to test the result of your provisioning code. And BATS is basically Bash automated testing system, so it's very simple Bash scripting, which allows you to create scripts in Bash which look like unit tests, but it just execute some Bash commands and give you a result. And another kind of sub-anti pattern for that is that ignoring styling guidelines for the tool that you use, from language that you use. This usually comes from the people who have more operational background, but rather than developing background, so they just don't care about the quality of the code or the structure of the code. They care more about the result, which is important, of course, but it's not that hard to follow the styling guidelines, and it makes things easier, making things easier to merge, to understand, and stuff like that. And again, there are quite many tools that, and for each of the provisioning tools, you actually have, like for Puppet, you have Puppet Link, for Ansible, you have Ansible Link, for Chef, you have Food Critic. Also, there's a shell check, which kind of allows you to verify your bash script or shell script. Also, there's YAML Link, which allows you to check the state and good practices, best practices for YAML configuration, because, well, there's a lot of YAML files around. Okay, I'm coming to the final group, which I didn't find a good name for. That's why I call it side effects, because when you have a lot of automation, using a lot of provisioning tools, you'll probably come to the realization that maybe I should also automate more stuff and stuff like that. One thing is metrics as code. And the thing is that metrics are quite important for any application, especially if you care about maintaining an operating-based application in production for real life for a long time. Then metrics are important and dashboards are important. The thing is that it is actually part of your application interface, and I think it should actually be evolving together with your application. So it probably should live close to the code where your application code is, and it should make it easy to be able to discover or visible. Most monitoring software has actually APIs and configuration files which you can extract and store somewhere in your provisioning code, in version control, obviously. And there's also plenty of libraries that allow to provide monitoring configuration for your applications with auto discovery and stuff like that. Or in Java, for example, I can name some monitoring components like drop wizard metrics, Citrix, stage monitor, something that you can inject into your application and also provide some useful metrics out of that. And another thing The next pattern is control panel as code. Well, I guess most of you guys have Jenkins servers or some CI server running for building, for deploying stuff. So eventually, if you invest more into automation, there will be more jobs that are not only responsible for building your code, testing your code, but also for deploying your code, for making some operational things like restarting servers, flushing the cache, orchestrating all these deployments, things like that. Most likely they will actually be part of some of the Jenkins code, for example. And and if you go that path, it's often that you have a lot of configurable jobs inside your Jenkins, but it becomes very essential for your operations to actually use that. But that code, that job configuration is not in the version control. It's not versioned in any way. It's not. There's no process around it. So actually, I've seen an example when one company lost their Jenkins server, and yeah, they had spent another 1.5 months to actually reproduce the configuration. And the thing is that, again, most of those tools have APIs. So most of the CI servers have APIs. Jenkins has Jenkins API, Jenkins has job DSL, and Jenkins has a Gradle plugin for job, which uses job DSL to define your job. So you can actually define the job configuration in version control and actually deploy the job configuration from your version control to Jenkins. So instead of going through UI and clicking there, you have actually a reproducible Jenkins setup, which may become very important at some point if you have many jobs and you're basically reliant on that as your control plan. Also, in case of there's other tools like that. For example, I know Rundeck. I use it a bit. It also has API and also command line. I think most of other CI servers also has that, and I think it's quite important at some point to actually extract the configuration, put it in version control, make it deployable as well. Yeah, it's another one. It's already answered button. The private fork of a community module. So Publish Ansible has a lot of modules available on GitHub. They have a lot of modules available on their module repositories. Not all of that code is good. Some of that code is maybe early stage or solving any particular use cases. So I've noticed a lot that people take some public module, in-source it, and then change it and never get back, and then never share it back. So of course it's not nice, because I think the power of these tools like Ansible, Chef, Puppet, and others, it's a lot about community. So it's important to share it back, because that's how we get benefits. And if you actually need to use some module work, if you need to use some community module that doesn't solve your problem completely, maybe create a wrapper around that module, which will allow to sharing that is simpler, and the upgrade of the module will be much simpler for you, because you can isolate the boundaries. That's my favorite antipattern, and that's kind of not really signaling. That doesn't really relate to the code that much, more relates to the organization of the team, and I call it other stuff, and you will understand why in a second. So, and usually it's because there's no alignment of the team, and they just want to contribute, but they don't know how. So imagine at some point you have this nice structure which have some definitions, some procedures, some configuration, some scripts, and everybody knows how it works. And then suddenly another group of the in your project decides to contribute to that, but they don't know how. So what they do, they create a directory called other stuff, which obviously violates naming conventions, which obviously doesn't fit anywhere, but it indicates much deeper problems in the team, because you have to communicate this stuff with other guys. And of course, because it's code, it's easy to create big balls out of that. And that's with other stuff you can go very fast and get very unmaintainable code base. And the last pattern, automation over documentation. So I think many operational departments actually suffer from either managing or not managing the documents, which become outdated very fast. So I think code will tell it much better. So if you can express yourself, your architecture, your deployments, your control panel, your metrics in code, it will be much better than having large Word documents that nobody updates. So automation over documentation is quite important. Okay, conclusion. I have the summary patterns here. I will share the slides later on, so you can actually grab it list. And I think that's it. Well, thank you very much.